All right, you need to see the first one. Okay. Please draw a picture. You want to get it right, you're going to want to at least plot the points so you know what quadrant you're in, so you know what your signs are. Just don't draw a triangle. Pictures. Ordered pairs. X and Y axis. That's why you're given an ordered pair. You're not always going to be given one, like the first bonus, but you're given information about it so you can plot it in the correct quadrant. First of all, appropriate work to receive credit. Correct answer is not enough. Why does it keep moving my little thing? Now show work for support your answer. Simplify, reduce final answer lowest terms. Only decimals when the directions say so, round appropriately. Final solutions in a given space when provided, unless directions specifically ask you to convert into measurements, answer the questions in the original minute. Okay, so exact value, so no decimals. -8, -15 is in quadrant 3. So 8 to the left, down 15. You don't have to like put 8 little notches, 15 little, just left, down. Somewhere right here is the ordered pair -8, -15. Now, make a triangle. Pictures. You have a radius. You always with the x-axis. Always with the x-axis is how you make your triangle. There's your right angle. The sides of the triangle. Y is 15, -15 down, so the length of the triangle is 15. X left is -8, so the length of the triangle is 8. If you're going to do anything, you're going to have to know the radius, because the sine is the y over the radius, cosine is x over the radius, tangent is the y over the x. You have y and x, so you can technically take care of that. You can take care of cotangent, but you need the radius to do the other 4. Now, here's what, keep this in mind. I know I'm in quadrant 3. All the trig functions are positive in quadrant 1. Only the sine and cosecant, the reciprocal, are positive in quadrant 2. Tangent and cotangent. Tangent is positive in quadrant 3. In quadrant 4, it's only the cosine function and the secant function, the reciprocal, are positive in quadrant 4. If you're not positive, you must be negative. So in quadrant 3, the only positive is tangent, because it would be y over x, negative over negative, -15 over -8, positive 15 over 8. So that means sine is going to be negative, cosine is going to be negative, cosecant is going to be negative, secant is going to be negative. I got the signs ready. I just need my x's, y's, and r's. I need my r. Hello, Pythagorean theorem. Okay, just Pythagorean theorem in the picture. And this is why I don't want to use the actual x and the y, because I know you guys, not just some in general, the entire history of all the students I've ever taught don't take care of negatives properly. The radius is equal to the square root of x squared plus y squared. X would be -8 and -15 for y. People don't use parentheses like they should. So just use the triangle. Square root of 8 squared plus 15 squared. So the radius is equal to the square root of 64 plus 225. So the radius is the square root of 289. And the square root of 289 is a 17. So in my picture, always good, put a 17 in there. It's not going to hurt. So now sine is the y. you already have your negative. So the y is 15 over 17. The cosine is the x, you already have the negative, 8 over 17. And the tangent is the y over the x, so that's the 15 over the 8. Cosecant, flip over your sine, so it's negative 17 over 15. Secant, flip over your cosine, so it's negative 17 over 8. And cotangent, flip over your tangent, so that's 8 over 15. Any questions? Any problem with number 2? The answer is quadrant 3. So you were told, and when you decipher the way this is written, identify the quadrant in which the angle theta lies. So where is angle theta? Make sure you use Roman numerals on the main quadrant. Cosine theta is less than 0. So that means what they're saying is the cosine of a theta less than 0, it's a negative. Cosecant theta is less than 0. So they're saying cosecant theta is also a negative. Now here's my brain. My brain does not process the reciprocals very well. I don't process cosecant, secant, and tangent nearly as well as SOHCAHTOA, sine, cosine, tangent. So SOHCAHTOA is not as easy for my brain to figure out as SOHCAHTOA is. Cosecant is the reciprocal of sine. So if cosecant is negative, that just means that sine theta would also be less than 0. So sine theta is also there. That's what you're being told. Cosine theta is negative, sine theta is negative. So one at a time. Let's start with cosine. You know that cosine, everybody is positive in quadrant 1, and cosine is positive in quadrant 4. 1 and 4, that's where cosine is positive. So therefore, cosine is negative in quadrant 2 and quadrant 3. That's where cosine would be negative. That would be the answer, possible answer, if it was just this. Now we do this. Start with what you know. Sine is positive. Everybody's positive quadrant 1. Sine is positive in quadrant 2. Therefore, sine has to be negative down below where the y's are negative. Sine is negative in quadrant 3, and sine is negative in quadrant 4. So where are both of them true at the same time? In quadrant 3. Okay. It's like a little Venn diagram. Okay.
Robert went to his little house and
Where's the, so you have this set of clues and these set of clues, and where do the clues overlap? Because that's where it happens. Yeah. But you have to read the mathematics. That's the problem. You've never had to read math before and make sense of it. Don't make me say it. Okay, question 3 and 4. Referencing. Remember, the reference angle is an acute angle, which means it's between 0 and 90. I can refer this angle of 973 degrees. I can refer it to some reference angle, theta prime, that's in quadrant 1. It's the amount of opening between the given angle and the x-axis, the horizontal axis. So the answer comes out to be 73 degrees. Anyone need to see it? Okay. Pictures help me. I'm going to start with pictures. 973 degrees. So let's see where that's actually where it's going to be. So when you make this little revolutions, when you go around once, that's 360. 1.5 times is 540. 2 full revolutions. 2 full revolutions, you are now at 720 degrees. 2 times 360. If you go around another half a time, so 2.5 revolutions, 720 plus another 180, you're at 900 degrees. Okay, 900 degrees when you're on the negative side of the x-axis. So if we continue all the way 1 more revolution, we passed this. This is 1008. So it's somewhere between quadrant 3 and quadrant 4, and that's going to be make the difference between what we do. So the question is, did we end up in quadrant 3 or 4? If you go only 90, this is 990 degrees. So the question is 973 between 900 and 990, or between 990 and 1008? It's in quadrant 3. 973 degrees terminates in quadrant 3. Now remember what we could do when we found coterminal angles. When we did coterminal angles, we just wanted to find another angle that terminated on the same ray. So you went 973 and you took away 360, and you got 3, you got 1, and you got 6. And that's still more than 1 revolution. So if you take another 360 away, so 3, and then that's a 5, and then 3, so I have to borrow, so that's 5 now, and that's an 11. So that's a 253. 253 is between 0 and 360. So that would be 253 is past 108. But not more than 270, so it's still in quadrant 3. So your job is to figure out if it terminates in quadrant 3, then basically, how big is this angle between your angle and the x-axis? Well, if this is 900, and that's 973, the difference is 73 degrees, and that's what your reference angle in quadrant 1 would be. Because if you wanted to look up the tangent or sine or cosine of 973 degrees in a textbook, it wouldn't be there. You'd have to find the reference angle, and you would look up 73 degrees. If you did the coterminal angle and converted it to 253 degrees, then you just, again, you subtract 180, and you would still get 73 degrees. On number 4, when it's given in radians, well, first of all, pay attention to direction, because you're going to want to know what quadrant you're in. That's a negative 11 pi over 4. Pi over 4. So we're basically counting by quarter pies. So you got 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. Hey, that's 8/4 because it's 2 pi, negative 2 pi. That's negative 8 pi over 4. Okay. We want 11. So negative 9 over 4, negative 10 over 4, and right here. Right there is where negative 11 pi over 4, negative 11 pi over 4 terminates. So again, the reference angle is the opening to the x-axis. And how far is that opening? Well, if this is quarter pies, then that must be a quarter pi of opening right there. Positive. Because the reference angle is always between 0 and 90 or 0 to pi over 2. It would never be negative. It would never be more than 90. Would never be more than pi over 2. Would never be less than 0. Never be less than 0 radians. So there's a pi over 4 opening right there. Pi over 4. Now, you could have reference angle, sorry, coterminal, because it's negative. To go back the other way, we add 2 pi and find a coterminal angle. So that would be negative 11 pi over 4, plus this would be 8 pi over 4 when you get a common denominator. Negative 11 pi plus 8 pi is negative 3 pi over 4. So the coterminal angle is negative 3 pi over 4. And if that's 3/4, then that must be 1/4 to make a whole pi. Okay. Any clarification? The reason why I put a negative on there is so you would think about quadrants. Because if I would have said positive 11 pi over 4, well, positive 11 pi over 4, so we go this way, there's 8 over 4, 9, 10, that's in quadrant 2. Okay. And the difference is instead of going well, still looking at it, you can still see that's a pi over 4 over. But this way, it's, you know, that's 3 pi over 4. So it's pi minus 3 pi over 4. But I don't like doing it that way. I like seeing how much I just have to add or subtract, not memorizing formulas. There are formulas, but the formula is only good for 0 to 360. So you have to find a coterminal angle every time. The visual for me makes a difference. Plus, it's fun to go around. So it's called the spiral of Archimedes. It's not exactly a spiral, but it is close. Okay. Bonus. Now understand the bonus that you're looking at is an actual test question for the week of the test. And please, let's change history. Those that don't study history are doomed to repeat it, so I'll give you a chance to study a little bit of history. To learn from previous classes' mistakes. Draw a freaking picture. Graph the triangle in the appropriate quadrant. Don't just graph a triangle, but graph it in the correct quadrant. Because if you don't put it in the right quadrant, you're not going to remember to put the right signs, SIGNs. And students, they just ignore this. It's like, I don't even understand what that means. So I think that if I ignore it, it doesn't exist. Okay. So if I have a problem and choose to not deal with it, then it doesn't exist. Make sure you get 2 of these problems right. Cosecant, negative 109 over 91. So sine is negative 91 over 109. Okay. Again, I've had students, they don't even put that in. Make it better. And again, Choshak, not my best of friend. I understand and process SOHCAHTOA better, so that's why this helps me. Sine theta is negative 91 over 109. Remember, that is y over r. So I know y and r, the ratio of y and r. I also know what quadrant theta is in. Theta is between pi radians and 3 pi over 2. Pi is 180. 3 pi over 2 is down here at 270. If theta terminates between pi and 3 pi over 2, that means theta is in quadrant 3. Now, number 1, terminating quadrant 3. So far I've had a lot of quadrant 3. That does not mean your quiz today is nothing but quadrant 3. Just making sure. So I'm just gonna, I don't need to make a perfect, it's just I need to put my angle here in quadrant 3. That's red pin. The y is a 91. The radius is a 109. I don't know what x is. To figure out cosine and tangent, I'm going to need to know the x. So in my right triangle, x squared plus 91 squared is equal to 109 squared. So x squared plus 91 squared and while I'm standing over here, I'm going to go ahead and square my 109 as well. So x squared plus 8,281 is equal to 11,881. Subtract. Subtract 8,281 from both sides. And x squared is equal to 0, 0, 6, and 11 minus 6, 3,600. Oh, look how nice this number is. Take the square root. And the square root of 3,600 is 60. So x is a 60. Okay, 60. So the cosine, and I should have done this. Hang on, I messed up. Where in quadrant 3, cosine would have been negative, secant would have been negative. Tangent, cotangent is going to be positive. Now, x over the radius, 60 over 109. Secant, flip it over, 109 over 60. Tangent is y over x. The y is 91, the x is 60. It's a negative 91 over a negative 60. That's why tangent is positive. Cotangent, flip over the tangent, 60 over the 91. If it reduces, make sure you reduce it. That doesn't reduce. Any clarification? Bonus is just like that, with just a different trig function, different interval. Answer all 6. Okay. And then the second bonus question. Find the reference angle for the given angle. Round your final answer to 4 decimal places. Theta is 14.6. Make sure you get whether or not it's radians or degrees. That's radians, because there's no degree symbol. Does it matter? If that was just 14.6 and there was a degree symbol, then that means data itself is in quadrant 1. So what is the reference angle you're looking at? It's 14.6. It is its own reference angle. The reference angle is something between 0 and 90, and itself is between 0 and 90. Done. Let's rate it. You're going to want to know what quadrant you're in. You're going to need to know, do I subtract pi, do I subtract pi, or do I subtract from pi? Do I subtract 2 pi, or do I subtract from 2 pi? Don't forget, pi over 2 is approximately 1.57. Pi, 3.14. 2 pi, 6.28. 3 pi. Well, if I take 3 times 3.14, it's going to be about 9 times 3 is going to be 4.2. 4 pi. 4 pi is approximately 4 times 3.14, so that's 12.56. Approximately. I mean, we can punch it in and get more of a better answer, but I just need to know approximately. Have I passed the given angle? No. 5 pi. So 5 times 3.14 would be 15. And then 5 times about 15.70 something, or close to it, again, close to it. Have I passed the given angle? So it looks like this angle is somewhere between 4 pi and 5 pi. So 1 pi, 2 pi, 3 pi, 4 pi, and then here all the way going around is to 5 pi. And it's somewhere in between. Now the question is, does it end in quadrant 1 or quadrant 2? Because that's right now my 2 choices. So the dividing amount is that pi over 2 between. Remember, this is about 1.57 either way. So if I take 4 pi and go plus 1.57, then basically you're looking at 4.5 pi, 9 pi over 2, 4.5. That midway mark. And that would be, that's a 3, carry the 1, that's an 11, that's about 14.13. Right about there, approximately. So if we went once, 2 times around and stopped right here, this would be approximately 14.13. And again, that's a really rough estimate. Am I there? No. It's past that because it's bigger than that. So it's somewhere here in quadrant 2. So to get this little amount of opening, you take the 5 pi that it would have been, and you got to subtract the measure of the angle. That would be as close to an exact answer as I could get, but we want 4 decimal places. So now on a calculator, this is what I'm going to punch in. Let me move this over to the right-hand side and let me erase and see what the heck's going on. So 5 times pi, so 5, and then I press the pi button. And then I go minus, and I go 14.6. That simple. So the amount of opening right here, that 5 pi minus 14.6 is 1.107963268. Zero. And then to 4 decimal places. Have we lost? Is there one that I left out? I did when I copied it down from my calculator. I left off one. So that's wrong. That's why I shouldn't work at night. 4 decimal places. That 6 rounds this to a 10. So that 10 rounds this to an 80 or an 80. 1.108. Do I need to put the 0? Yes. Yes. 1.1080 because the directions take 4 decimal places. That means I gotta have 4 places. I gotta have 4 digits. If I don't put the 0, that means it looks like maybe I rounded to 3 decimal places. Maybe something rounded that 3rd digit to an 8, or maybe it stayed an 8 and was an 8 originally. I don't know where that 8 came from. When there's that 4th place, now I know that something in the 10th, 100,000, 10,000, something in the 100,000th place rounded this to an 80 or left it an 8. Okay, there's a small difference, but follow directions. And that is your quiz at 12:30. Okay. We are picking up, finishing homework. I cannot finish some example. I didn't write down which one it was. Now I know what that movie absent-minded professor. Absent-minded professor did not have a phone that took pictures of what he did for all time. Number 7. We did so. We're still working our way through the odds to 101. 71 to 81, you're on your own because you're just punching it up on your calculator. They want you to, oh, my bad, you're not on your own. I think that's without using a calculator. Whenever you're not using a calculator, whenever it says no calculator or exact value, it must be one of our special items, or a 0, 90, 180, 270, 360, or multiples of it. Because that's the only way to do it without a calculator for right now, and that's the only way to get these exact answers. So 225, and while you're doing homework, you can always use your unit circle. And they want just sine, cosine, and tangent. They don't want all 6, so sine, cosine, and tangent. So 225, first of all, I know tangent. It's a 45-degree angle, right? Well, technically, I know. It's a 45 because the only special angles that end in 5 are the 45 degrees, right? Those are 45 degrees. If it ends in a 5, it's a 45-degree angle. Okay? As a special, 15 degrees is not a special. But multiple is 45. The only answers that come out of sine, cosine, and tangent. Sine and cosine are the same because it's an isosceles. 1 over square root 2 or square root 2 over 2 if you rationalize. Sine. That's quadrant 1. Tangent, because x and y are the same, is 1. Tangent is always 1. 225 is in quadrant 3. Tangent's positive, so sine and cosine have to be negative. So the sine and cosine of 225 are both negative root 2 over 2s, and the tangent is positive 1. 225. The sine, negative square root 2 over 2. Cosine, cosine, negative square root 2 over 2. And tangent is this y over this x, since they're the same thing, positive 1. The reference angle for 225 is just this 45-degree angle. So you can just use those and then put your appropriate SIGNs, your sines. Sine and cosine are negative answers, tangent are positive. Now 750 is not, I don't know which one that is, but I know 2 revolutions is 720. 2 times around is exactly 720. It's negative. So that means you're going this way. 360 negative, negative 720. So you must be going into quadrant 4, and that's where negative 750 degrees is. You're in quadrant 4. So when you're doing 73, sine theta, cosine theta, tangent theta, in quadrant 4, the sine is negative and tangent's negative, but cosine's positive. The reference angle. How far did I go past the x-axis? I went 30 degrees past the x-axis. Remember, 2 times around was 720 degrees. So right there was negative 720. I went 30 degrees more. So the reference is 30 degrees in quadrant 1. So basically, I just need to know what's going on at 30. As you go around the unit circle, remember, the x's start out big at 0, x is 1. As you go around, x gets smaller, goes to 0. The y start out small, and as you go around, the y's go up to 1, so they get bigger. So at 30, your only numbers when you have 30 and 60, square root 3 over 2 and a 1/2. The smallest one is the 1/2. Smallest one is a 1/2. So sine is a negative 1/2. The cosine would be positive square root 3 over 2. Tangent gets bigger. Tangent gets bigger because right here, tangent is y over x. 0 over 1 is 0. As you go up, 45, tangent equal to 1. At 60, square root 3 over 2 divided by 1/2 is just square root 3. So it's going from 0 to 1 over square root 3 to 1 to square root 3. And then as you go up to 90, it's undefined because the denominator approaches 0, which means the whole answer is going to infinity. That means it's getting really big. Tangent's getting bigger, so that would be the smallest outside of 0. That's the smallest tangent answer, which is 1 over square root 3. And if you rationalize, you look at the back of the book, it's going to be negative square root 3 over 3. That's why you need to get to know your new best friend, the unit circle. And you need to fill out that 0 to 90 worksheet. And the 0 to 360 is also helpful, the big one that I gave you. You get to know it. So that's how you do, that's reference angle is pi over 3, reference angle is pi over 6, reference angle is pi over 4, reference angle is pi over 6. You just need to know what the signs are because of what quadrant these terminate in. Find the indicated, so that would be the far column on the right, the indicated trig value in the specified quadrant. So you're given one trig value, and then you got to find the one that they're asking you for, given a specified quadrant. So let's see. I'm not going to do sine because I'm going to be able to show you a sine because I'm going to do 85. 85 is a cosecant, which means I'm going to flip it over anyway. Well, 85 we're given the cosecant of theta is a -2. We're told that we are in quadrant 4. And we want, what is cotangent theta equal? Well, first of all, the cotangent of theta, because you're in quadrant 4, is it going to be a positive or a negative? It's going to be a negative. I got my sign right. Or took care of my sign. I wonder if I should draw it. Yeah. Again, old brain, I don't get it. Sine theta, what's the reciprocal of -2? -1/2. Flip it. So in quadrant 4, this is y over r. In quadrant 4, the y is a 1, the radius is a 2. If I'm doing cotangent, I'm probably going to figure out tangent first and then flip over my answer. So I'm going to need to figure out x. You should be able to just look at what we've got and know it off the top of your head. That's it. Square root of 3. Because if the hypotenuse is twice one of the legs, you have a 30, 60, 90 triangle. So if this hypotenuse is twice that leg, then that means this is the short leg. So that's technically 30 degrees, which makes that the long leg. That means 60 degrees. And that means the long leg is square root 3 times the short leg. Square root 3 times 1 is just square root 3. It's nice to know things from other classes that you've taken in the past, like geometry. What are the little tree stages of the monometry? Baby tree stages of the monometry. Geometry. Well, that kills them when like a 4. If you don't see it and know it, then guess who will tell you is Pythagorean theorem. X squared plus 1 squared equals 2 squared. X squared plus 1 equals 4, subtract 1. X squared equals 3. So x is the square root of 3. So my tangent is negative y over x, 1 over square root 3. So my cotangent would be negative square root 3 over 1 If you leave that as your final answer, you lose a point because it's not simplified. What's square root of 3 divided by 1? Just square root of 3. Always simplify the little term. Okay. You have all the information to figure out the pieces of the puzzle. You need to see it as a puzzle. Maybe you need to see pictures so you can fit the pieces together. If you're not drawing the pictures, then how are you supposed to fit the pieces? It's like, here's a 500-piece puzzle, but we're gonna not let you see what it looks like. Good luck. Okay. Some people can put it together. We hate people like that. Right, so that's, you do 83, do 87 that way. Now, very explicitly given to you what quadrant the angle is in. And 89 to 93, it's not explicit. So let's do 91. Just picking the one in the middle. Whenever I ask students, if I give them like, okay, what do you want to see? 89, 91, or 93? They always pick the last one. Because they think that's what the toughest one. If I show you one example, you should be able to do all. 91. The tangent of theta is -4. And the cosine of theta is less than 0. Now we want to find the remaining trig functions. So we got to find sine theta, just like basically today's quiz. Cosine theta is like a warm-up. Tangent theta, cosecant theta, secant theta, cotangent theta. Well, good news, they gave you one of them. And if you know this one, what else do we know? What's cotangent? -1. Very simple. Okay. Tangent's negative. The only quadrant tangent positive in is quadrant 1 and 3. So if tangent's negative, right now it's possible that it's 2 or 4. Cosine is less than 0. So that means cosine is a negative. Well, cosine is negative in quadrant 2 and quadrant 3. So where these two things are both true at the same time has to be quadrant 2. This angle is a quadrant 2 angle. Okay? If it's in quadrant 2, sine is positive, but cosine is going to be a negative, which they actually told me. If I'm going to draw a picture of this, remember tangent is y over x. But all I have is -4. You can write this as a fraction. What is 4 as a fraction? What is -4 as a fraction? It's just 4 over 1. So my y would be a 4 and my x would be a 1. Remember, it's just a ratio. 4 over 1 is the same as, it could be an 8 over 2. It could be a 12 over 3. It's just a ratio. So use 4 over a 1. So in quadrant 2, here's my angle. Make a triangle with the x-axis. The y on my triangle, that's a 4. This x down below side of the triangle is 1. To figure out the other 4, I need the radius. And 1 squared plus 4 squared is equal to the radius squared. So 1 plus 16 is equal to the square of the radius. So 1 plus 16 is 17. And when you take the square root, the radius is the square root of 17. It does not simplify, that's it, square root of 17. So the sine is just your y. The y is 4. 4 over the square root of 17. You leave it like that. In the back of the book, they're going to have 4 square root 17 over 17. But if you leave it like this, look how nice the cosecant. Flip it over. Square root of 17 over 4. The cosine is the x over the radius. 1 over square root of 17. And I already have my negative in place. Negative 1 over square root 17. In the back of the book, it's going to be negative square root 17 over 17. The secant, look how nice, flip it over, just negative square root 17. They only gave me one ratio, but they gave me a clue about where it is. So I know the signs of everything else, and I can make a triangle and figure out everything. This time it wasn't a Pythagorean triple. It didn't come out to a nice number. That's okay. Radicals and besides 2. Remember, a radical just means it doesn't come out to be a nice integer. All right. So now 95. Now you're on it. This is plugging into your calculator. But what's really important, if you look in the back of the book and it's not right, use your calculator in the right mode. 95, it's 105. You got to be in degrees. 97, you're in degrees. But 99 and 101, those are radians. You're just supposed to plug it into your calculator, round your answer to 4 decimal places. If you see this, these are not any of our special angles. These are not going, you're not going to be able to get exact answers. There's none of the radians are over 9. Our special radian answers are 1/6 of pi, 1/4 of pi, 1/3 of pi, or pi over 2, 1/2 of pi, or whole pies. Okay, but not ninths. Make sure you're right mode. One odd, so that takes care of that. And then we're going 103 to 111 every other. So 103, evaluate the function for the given values of t. So they want you to f of, plug in 3, f of 3. And then do it for pi, f of pi. And then f of, in the second one, f of 0.3. And then for part B, f of negative pi over 4. Should you be in degrees or radians? Radians, because none of those have degrees. So you just punch it up in a calculator. Well, 7 to 111. Find the 2 solutions of each equation. Give your solutions in both degrees and in radians. Do not use a calculator. Right. Totally inappropriate joke, because this whiteboard makes my butt. Okay, edit that out. I actually made one of my classes chuckle. It was shorter. It wasn't Charlie. Shirley wasn't you guys. Solving for theta. Solving for theta. If you look at the right side of the equals, if you look at the right-hand side of the equals, all of these answers over here are special ratios that we get every single time. Now, you may not recognize 2 squared 3 over 3, but it is one of the rationalized answers that we would get. If we flip it over, I'll show you. But I'm going to show you 107, and I'll show you 109. Okay? Because I know you're supposed to do all the way to 111 every other odd, but one of those is going to be the ones you have. So on 107A, you're given the sine of theta is equal to exactly 1/2, and you're supposed to find all the answers for theta in degrees. And then what are those answers for theta in radians? Now, you only want the answers that are greater than or equal to 0 degrees, but less than 360 degrees. It has to be between 0 to 360. Learn from the past. I get people that give me negative answers. Oh, the answer is negative 45 degrees. Okay, directions say bigger than 0. Do I tell them what I'm telling you right now? Do I say it like every semester I got to teach? Do they still do it? Is it more than one person? I feel like one of those little bobblehead dogs. And it's like, do they do it on more than one test? Because you know what? It's going to equal 1/2 an infinite number of times. We only want 2. From 0 to 360 or between 0 to 2 pi in radians. 0, there's no degree symbol, but less than 2 pi. And if you notice the 360 and the 2 pi, there's no equals on them. Because when you get to 360, that's just the same as 0 degrees. And we already have equal to 0, so we're not going to repeat it by putting 360. Same as 2 pi. 2 pi radians is the same as 0 radians. So if the answer is 0 radians, and then it happens again at 2 pi radians, well, we already have that. So we wouldn't write it twice. So that's why not equal to 2 pi. We already have the 0. These functions are periodic. That means they happen multiple times over a given interval. Okay. When you went to high school, you have periods of the day. What period is your English class? What period is your math class? What period is your history class? Because every day you went to those periods, or every other day. It happens in a cycle of times. Okay. Periodic. Okay. We know that the sine of an angle equals 1/2. It's a sine of a special angle. And I mentioned it's the only one that I know by heart. And if I pull up my unit circle, I now need here. What I need is this, that, and that. Sine is the y value. When is y? And again, it's about quadrant one. In quadrant one, when is y 1/2 at 30 degrees? That's the only one I remember. Really, that's it. If I know that one, I know everything. And again, not taking into account 45. 45 degrees is an isosceles. Isosceles has two equal sides. Isosceles, that's the one that has a square root of 2 in it for sine and cosine. That's square root 2's in it. So when I see something equal to something with a square root of 2, that must be the pi over 4 and the 45 degree answers. When it's a 1/2 or a square root 3, 30, 60, 90, 3 different angles, that's the one that has square root of 3 in it, square root 3 over 2. Which one? Sine starts off small and gets bigger, 0 to the 1/2. So the first answer is 30 degrees. There's my 1/2. Or you also can do your little your finger sine, cosine tangents. From 0 to 360, when is the sine equal to positive 1/2 again? So sine is the y. Where is the y? When is the y positive 1/2 one more time? Right here. Yeah. At 150 degrees. There it is. Let's talk reference angles. The first answer we found was in quadrant one. And the answer was 30. Now, where is sine positive? Because it was positive 1/2. Sine is positive in quadrant one and quadrant two. So you know the first answer, quadrant one, 30 degrees. So that means in quadrant two, the answer needs to be 30 degrees from the x-axis. So who's 30 degrees from the x-axis? Now remember, going this way. That's 150. So there's my two answers, 30 and 150 are my two answers. Now, if you keep going around the circle down here, it's a negative 1/2, and over here it's a negative 1/2, and then it repeats. We already have this answer. We've already been here. So that's why we stop from 0 to 360. And if we know the answers in degrees, we got the answers in radians. That's pi over 6. And that's 5 pi over 6. Okay? So if you know quadrant one, you know everything. It's just about what's my SIGM, what sign is it? So I know what quadrant to look in. But what is it going to match up with? Is it part of the 30, 60, 90 group, or is it part of the 45, 45? Part B, 107 part B. I believe it was sine of theta was negative 1/2. All right. Yeah, you don't have to look out for it. You have a photograph of memory. Yeah, negative 1/2. So this is what students do. They think I'm just going to use my calculator. If I do this, and your calculator can figure this out. It's the inverse trig button. The inverse sine of negative 1/2. Because basically, if the sine of theta is negative 1/2, then the inverse sine of negative 1/2 is going to tell me what theta is. So make sure I'm in degrees. degrees. So I go second, and I hit inverse sine, and I go negative 1/2. And close that parentheses, and I hit enter. The calculator says negative 30 degrees. So what do they put? Negative 30 degrees. What do the directions say? Between 0 and 360. And what do they tell me? Well, my calculator said negative 30. Your calculator's right, because that's what you punched in. But you didn't answer the question the way the question is phrased. So when you are supposed to use a calculator, I tell students, don't plug in the negatives. Just don't. Don't plug in negative. Forget about the negative. Just forget about the negative, and let's focus on where is the sine of theta positive 100. Think quadrant 1. Sine of theta is positive 1/2 when theta is 30 degrees. That's my reference angle. Think about the reference angle. So the reference is 30 degrees. Now let's focus on the negative. What quadrant is sine negative in? Sine is negative in quadrant 3 and 4. That's where sine is negative. So that means you would have an angle like this, 30 degrees from that x-axis and 30 degrees from this x-axis. That reference angle is going to help me figure out what my actual answers are. So when you go from 0 to 360, 30 degrees past 210, sorry, past 180, that's 210 degrees. And then this one is 30 degrees short of 360. So 360 minus that little 30 degree opening is 330 degrees. But it's about knowing your first quadrant, and then you think, all right, where are my answers supposed to be? What quadrant are you supposed to be in? And then thinking through it. Sine is negative 1/2. Sine is negative 1/2. Those are my two y's that are negative 1/2. When we do the unit for 5B, in 5B, we're going to graph the sine function. We're actually going to graph what does it look like when you graph the sine curve? The sine curve does this. It's called a sine wave. And it looks like this. From 0 to 2 pi, this is 1 pi in the middle. And then it repeats because it's periodic and it goes on forever. But think about it, right up here is positive 1/2. Between 0 to 2 pi, it crosses that 1/2 line twice. And at negative 1/2 down here, there are 2 times over here where it equal to negative 1/2 from 0 to 2 pi. Okay, that's what we'll be working with. We're going to do, and that's section 5.4, 5.5, and 5.6. So radians. So 210 is 7 pi over 6, and 330 is 11 pi over 6. Because if the reference angle is 30, the reference angle is pi over 6. If the reference angle is pi over 6, this is 1 pi plus an extra pi over 6. So that's 7 pi over 6. And that's pi over 6 short of 2 pi. So 12 over 6 minus 1/6 is 11 over 6. And you got them right here. Get to know these numbers. And again, that's why I gave you charts. $109. And I'm just gonna do 109A, because if you look at 109B, cotangent is -1, cotangent -1. So that's a 45-degree angle. Okay, so where's cotangent, tangent negative, that would be quadrant 2 and quadrant 4. When is it 1 at 45? So you need a 45-degree angle in quadrant 2 and quadrant 4. But this one, 109, because that doesn't look familiar. Okay. 2 square root 3 over 3. My brain's done. Cosecant. Oh. Let's talk sine. So that must mean that the sine of theta would be 3 over 2 square root 3. Okay, still. Not ring a bell, doesn't look like any of the ones I know from special triangle. And the directions say no calculate. So it's still, it should be. Well, if I rationalize it, multiply by root 3 over root 3. So I have 3 square root 3 on the top. Down below, I have 2 times the 3. And you can see that the 3's reduce. So this sine of theta is actually square root of 3 divided by 2. That is one of our special triangles. That's in the 30, 60, 90. Now, sine, I know the half, that's the small angle, that's the 30. So when sine is square root 3 over 2, that must be the bigger of the 30, 60, so that must be the 60-degree angle. Cosecant is positive. So sine is positive. Sine is positive in quadrant 1 and 2. So we're dealing with 60 degrees here and 60 degrees here. So the first answer, 60 degrees. And the second answer in quadrant 2, the reference on this side is 60. So from 0, it's 120. And then radians, 60 is pi over 3. And 120 is 2 pi over 3. Right? Uh, 117 and 135, 117. Use the value of the trig function to evaluate each function. Okay. So odds and evens. In the identities that I gave you, the table of identities, and I posted. The sine of negative theta is equal to negative sine theta, which means the cosecant of negative theta is also equal to negative cosecant theta. Also in that realm, if it's sine, it's also tangent. Tangent of negative theta is equal to negative tangent theta. And the cotangent of negative theta is the opposite of cotangent theta. The only one that doesn't change, the even function, is cosine. The cosine of negative theta is the same as just regular cosine theta. That means the secant of negative theta is just good old secant theta. So on 117, we are told for part A, well, we're told at the top that the sine of some t, that's a positive 1/3. So the question is, what is the sine of the opposite of t? Well, according to this, if I take the opposite of theta, it's the opposite of the actual sine value. So the sine of negative t would be the negative sine of t. Sine of t is 1/3, so it's the opposite of 1/3. Okay. Cosecant. If I know sine of t, that means the cosecant of t is the reciprocal, 3/1. So that's just 3. And the cosecant of negative t, according to our identities, is negative cosecant t. So the cosecant of negative t would be the opposite of this, which is -3. Yeah, really not a lot of work you can show. I wrote it out so you could understand what happened. Okay. You want to see radians or degrees? Okay, so we'll do 127. Theta is 7π/6. And we'll do as many as we can in about 3 minutes. We'll do the rest. Don't forget, Monday, no school. So this is basically composition of functions and or arithmetic of functions. We're told that f of theta up in the directions is the sine of theta, and g of theta up in the directions is cosine theta. So for part A, what does f plus g of theta equal? Now, what that means, function notation, what you're supposed to do, that means you're supposed to, my bad, function f plus function g of theta means it's f of theta plus g of theta, which means it's, in this case, the sine of theta plus the cosine of theta. Those are my two functions. So that's what this notation is supposed to tell you. So now you're supposed to plug in 7π/6. So it's f plus g of 7π/6. So that means 7π sine of 7π/6 plus the cosine of 7π/6. Do not use a calculator because pi/6 is a special angle. Quadrant 1, pi/6. Sine is the small one, the half. Cosine is the bigger one, √3/2. But 7π/6, that's in quadrant 3. So the sine is going to be a negative 1/2 plus the cosine, quadrant 3, cosine is negative, negative square root 3/2. So that plus and negative is just minus. And you do have a common denominator, so that's just -1 minus square root 3 all over 2. You do the same thing with part B, you subtract them. Part C, you plug it into the G function and then you square it afterwards. D, it's function F times function G of the 7π/6. Multiply them together, but you got to take the sine and the cosine first. Now, E, F of 2 theta means, well, function F is sine theta. So that means when I plug in, if I replace this with a 2 theta, I replace that with a 2 theta. So when I plug in 2 theta into the function, it's the sine of 2 times theta. That 1 theta is now replaced with the 2 theta. You're just supposed to plug 7π/6 for the theta. F of 2 times 7π/6. So that's the sine of 2 times 7π/6. So that gives you the sine of 2 goes into 6 3 times, 7π/3. Well, it's a 3, so that means it's a pi/3, which means it's a 60-degree angle, reference angle. Sine of 60, that's my root 3/2. But I need to know pluses and minuses. What quadrant does that terminate? Well, 3 goes into 7 2 times with 1 left over, doesn't it? 2 1/3. 3 goes into 7 twice, that gives you 6 with 1 left over. So 2 times 2π, that's 1 revolution, with 1π/3 left over. We're in quadrant 1. So it's a positive square root 3/2. Okay. I'm sure we'll talk about 135 next Wednesday. But there ain't no school Monday. Don't show up. We'll be by yourself. Hey, right on the door. Not got. Okay. So you get to use notes. You know exactly what to expect. Make sure you're filling it out first and last name. Also, how to take a roll. Have a good weekend. Be safe. Don't do anything. Just sit.